Another impossible galaxy. That's how it begins, almost routinely now. With yet another James Webb Space Telescope discovery that makes astronomers sit up, scratch their heads and whisper, "This shouldn't exist." This time it's a massive barred spiral galaxy named J0107A, 10 times the size of the Milky Way, formed when the universe was still a cosmic infant. How can a galaxy like this exist, not billions of years in the making but already fully formed just 3 billion years after the Big Bang? Today, we're diving into Webb's latest revelations. Not just jaw-dropping images, but paradigm-shifting findings that may force us to rewrite everything we thought we knew about galaxy formation. Galaxies. The cosmic shapes that define our sky. Galaxies aren't all built the same. Astronomers classify them into 3 main types: elliptical, smooth, featureless ovals of stars; irregular, chaotic, misshapen, like cosmic train wrecks; spiral, elegant swirling disks like our own Milky Way. The Milky Way is a barred spiral galaxy, meaning its spiral arms extend from a bright, straight bar of stars and gas running through its center. This bar isn't just for looks. It's a dynamic conveyor belt, funneling gas inward to fuel new stars. But here's the twist. Bars aren't supposed to appear in young galaxies. They take time to form, or so we thought. Webb smashes expectations. Again. Back in 2022, Webb shocked astronomers by revealing that barred spiral galaxies were already roaming the universe 10 to 11 billion years ago. One of them, nicknamed Sears 2112, was so Milky Way-like it felt eerie, a twin born just 2.6 billion years after the Big Bang. Now comes J0107A, not the oldest but perhaps the most shocking. Discovered by a team led by Shuo Huang of the National Astronomical Observatory of Japan, this galaxy is more massive than any barred spiral we've ever seen at this stage in the universe. It's forming stars at 300 times the rate of the Milky Way. Its bar isn't just developed, it's hyperactive, channeling about 579 solar masses of gas per year toward the center. That's not just a record, it's a whole new category. This breaks the rules. According to astrophysicist Deanne Fisher, galaxies in the early universe shouldn't have bars at all. Why? Because those early galaxies were rich in gas, and that turbulence was believed to disrupt bar formation, and yet here's J0107A, massive, organized, and already mature. Even more baffling is the bar's composition: 70% gas, 30% stars. This is completely backwards from what we see in modern galaxies. It's like finding a full-grown tree in the middle of a wildfire. So what does this mean? It suggests galaxies could form bars and structure far earlier and more violently than we imagined. These bars might not be passive features either. They could be engines, accelerating star formation, stirring gas, even awakening the supermassive black holes at their cores. Webb isn't just seeing galaxies. It's seeing time, of course. Not all of Webb's finds are cosmic titans. Some are quiet, beautiful glimpses into life and death among the stars. Take the haunting image of planetary nebula NGC 1514 released around Easter. At first glance it looks like 2 colorful eggs nestled in a glowing basket. But this isn't a planetary object, it's the aftermath of a dying star. Roughly 1,500 light-years away, this nebula formed when a star ballooned into a red giant, then expelled its outer layers. Now, glowing gas surrounds a white dwarf, lit by the remaining heat. Thanks to Webb's infrared vision, we can now see this fleeting phase of a star's death in exquisite detail. It took 4,000 years to create, and will vanish in just a few thousand more. In cosmic terms, barely a blink. The chaos of birth. Herbig Haro, 49/50ths. Not all stellar activity is about endings. Herbig Haro objects represent the beginning, violent, fiery, and filled with promise. Young stars grow by feeding on surrounding gas, but they also blast some of it outward in the form of narrow, high-speed jets. These jets crash into nearby clouds, creating glowing, shock-heated structures that look like cosmic tornadoes. Webb's image of HH 49/50ths, located 630 light-years away in the constellation Chameleon, combines near and mid-infrared views. It reveals a stunning red-orange funnel stretching across space, the product of a newborn star maybe just 100,000 years old. A dance of twin suns, Lin 483. In the constellation Serpens, Lin 483 offers something even more dramatic. 2 young stars locked in a fiery ballet, launching twin jets of gas into space. The result is a glowing V-shaped structure, orange arcs, violet columns, and a bright impact front where material slams into denser gas. The stars themselves are hidden behind a dense, dusty disk barely a pixel wide. But over millions of years that disk could evolve into something extraordinary. A planet-forming nursery and maybe, one day, life. What it all means with every image, the James Webb Space Telescope reminds us of something vital. We don't know as much as we thought. A galaxy that forms too fast, a bar that shouldn't be there, gas flows that break every rule, twin suns creating a firestorm, nebulas that vanish in the blink of a galactic eye. All of it points to one simple truth. Our universe is far more complex, dynamic, and surprising than we imagined, and maybe that's the point. Every discovery is a doorway. Every contradiction, a challenge, every unexpected galaxy, a reminder that science doesn't move in straight lines, it spirals, just like the galaxies it studies. So if you're fascinated by the cosmos, don't miss what comes next. Click like, hit subscribe, and join us as we keep exploring the universe, one impossible discovery at a time. We'll see you out there.